Okay, welcome back everyone. In this video, we are going to talk about Gauss Jordan method, that is a modification of Gauss elimination method. So this is basically modification of Gauss elimination method. So in Gauss elimination method, basically we had this Ax is equal to b, and from this A we were trying to convert this matrix with ux is equal to b prime, where this u was upper triangular matrix. So that was the idea, that somehow with the help of row operations we were trying to convert this matrix A into upper triangular matrix. Now in this Gauss elimination, this matrix A will be converted into Ix is equal to B double prime, where this I is nothing but identity matrix. This is an identity matrix, so that we can directly solve this x is equal to b double prime. Now let us understand that how to get this identity matrix from this Ax is equal to b. Now I have this matrix system that is given as A11, A21, A31, A12, A22, A32, A13, A23, A33. So this is my matrix A, and then I have this vector x1, x2 and x3, and that is equal to b1, b2 and b3. So the first row operation that I am going to do is, step 1 is r1 is as r1 divided by a11. So what I am doing is that basically I am dividing the first row bit a11, so that will make it as 1 and a12 prime, a13 prime, a21, a22, a23, a31, a32, a33, and then we have this x1, x2 and x3, and that is essentially equal to b1 prime, b2, b3. Step 2 will be r2 is nothing but r2 minus a21 times r1, and r3 is nothing but r3 minus a31 times r1. So what we are doing, we are trying to make this element and this element as 0 by taking this one as pivot. Okay, so this is my first pivot. I am taking this as a first pivot. So what will happen, my by doing that row operation step 2 which I said, we will get a modified matrix as A1100, and then we will have A12 prime, A22 prime, A32 prime. We will have this A13 prime, A23 prime, A33 prime, and this x1, x2, x3 will be intact, and then we will have this as b1 prime, b2 prime and b3 prime. So this is what we will get from step uh, 3, step 2. Now this element we will try to make it as pivot, but not like this. We will make this as 1. So step 3 will be r2 is r2 upon a22 prime. So that is my step 3. So what will come out of that is 1 0 0 a12 prime, a13 prime, this is 1, a23 double prime, a32 prime, a33 prime, and then this will be x1, x2 and x3, and we will have b1 prime, since there is only one operation applied to this b1, and then we will have b2 double prime, since two operations have already been applied to this b2, and then we will have b3. So after this step we got this. Now my step 4 will be that R3 is nothing but R3 minus A32 prime times R2. So that is my step 4. Now after this step 4, what I will get is this 1 0 0 A12 prime 1, and this will be 0, A13 prime, A23 double prime, A33 double prime, and then we have this B1, sorry, X1, X2, X3, and then we have this B1 prime, B2 double prime, and then we have this B3 double prime. Now my step 4 will be, sorry, this is my step 5. The step 5 will be, I will try to make this as 1. R3 is nothing but R3 upon A33 prime. Okay, so what we have got out of this step is that 1 0 0 A12 prime 1 0 A13 prime A23 double prime, and then we have this 1 as x1 x2 x3 equal to b1 prime b2 double prime and then b3 triple prime, since we have already applied 3 operations to it. Now let us do this. The step 5 will be the step 6. This is my step 6. Is R2 is nothing but R2 minus A23 double prime R3. So what will happen? I am subtracting this minus this. So what will come out of it is that this 1 A12 prime A13 prime 0 1 0 0 0 1. Okay, and then x1 x2 x3 is equal to b1 prime b2 triple prime, since 3 operations have already been applied to this, and then we will have b3 triple prime, since 3 operations have already been applied to it. Now my next step, that is step 7, that will be R1 is nothing but R1 minus A13 prime R3. So what will come out of this? This will make it as 1 A12 double prime 0 0 1 0 0 0 1, and then we have this x1 x2 and x3. Now remember, there are only 2 operations applied to it, b1 double prime, b2 triple prime, since 3 operations have been applied to it, b3 triple prime. Okay, now my last step is step 8 is what? R1 is equal to R1 minus A12 double prime R2. Now this is my, so I am trying to make this as 0. So what will this give me? This will give me as 1 0 0 0 1 0 0 0 1, and then we have this x1 x2 and x3 equal to b1 triple prime b2 triple prime, sorry, this is only triple prime, and b3 triple prime, and this makes it as x1 x2 x3 is nothing but b1 triple prime b2 triple prime b3 triple prime. So directly we got the solution. Can you see this? That x1 is nothing but b1 triple prime, x2 is nothing but b2 triple prime, and x3 is nothing but b3 triple prime. Simply, there is no forward substitution, or so forward substitution we have already done, but there is no backward substitution, back substitution as such in this Gauss elimination method. But now let us see that how many operations we have applied. We have applied b1 triple prime, that means 3 operation on the first row, b2 triple prime, that means 3 operation on the second row, b3 triple prime, that means 3 operations on the second. So if the matrix is of 3 cross 3, then total operations, how many total operations I have applied? Now 9. So this makes it a, n to the power 2, order of n to the power 2. Now this is order of n to the power 2, but since I need to calculate x1, x2 and x3 also, so there is one operation in the end, and there is one operation in the end, there is one operation in the end. So totally it makes is n cube. There are total basically, sorry, let us not, this is not operation, because here we are not doing any operation as such, because this is like equating only. So here 3, that means 9 operations are applied. So that makes it order of n square. And yes, that is true. So 3 operations are also there here, so we will have n to the power 3. So order of total number of computation is total number of computation is n की power q. So this is the order of this Gauss elimination method. I hope you got this idea. Now remember, we talked about if we are not able to find a proper pivot, then either we can exchange rows, and that is called partial pivoting. And if we exchange rows, suppose if we are exchanging rows, then B will change, but X will remain same, and we can change column, and that is called complete pivoting. So in this case, B will not change, X will change. What I mean to say is that B will change means B1, B2, B3 will become B1, B3, B2, since we are changing rows. Here X1, X2, X3 will become X1, X3, X2, since we are changing the column. So this you must remember that if we are not able to find a proper pivot, that means the diagonal element has become 0, then we need to exchange the rows in such a way that the diagonal element becomes non-zero. So that is basically the idea behind finding a pivot. And to find a pivot, we need either partial pivoting and complete pivoting. And in partial pivoting, basically the B changes, X remains in the same order, that means X1, X2 and X3. And the complete pivoting, X changes, that means X1, X2, X3 will change the order. It will become X1, X2, X3 will become X1, X3, X2, or X3, X1, X2, whatever way we exchange the columns. So in that case, this a this X will change, and order of operation is NQ. Okay, so I guess I gave you the enough idea of this Gauss elimination method. Let me talk about order of certain algorithms. That's what are the order of steps. Or let's leave it because it is not important. So let us go to the indirect methods or iterative methods. Or before going to that, we will talk about some more methods like symmetry, like LU decomposition method, and then we will talk about Cholesky method, Thomas algorithm, that is very important. We will talk about these algorithms in detail in the upcoming videos. I hope I am giving you material, and if you want to follow these algorithms properly, then you must follow this book by Chapra and Canal. I am saying again and again that you must follow this book, Chapra and Canal. Let me give you the exact uh, name of the book, Chapra. So the name of this book is called Numericals Methods for Engineers. So the name of the book is Numericals Methods for Engineers with Programming and Software Applications, and it is written by Raymond Kennel and Stephen C. Chapra. So these are the authors and this is the name of the book. All the details of whatever I am talking you can find in this book. Thank you so much.